Hear me? I ask everybody to please mute yourself. Please mute yourself. Hey Bharat, Zika, you are requested to mute yourself. Razika, can you mute yourself? Bharat, please mute yourself.
What? This is a better option.
నేను సరే అని చెప్పేసి నువ్వు ఛాన్స్ తప్పైతే పెట్టుకుని కొనొద్దు
Mute yourself.
No, the time has come. Succeeded.
Could you please mute yourself, Megha? Megha, Prasanna, could you mute yourself, please?
ఇక ఊరికి ఇప్పుడే ప్రచారం ఇప్పుడు చెప్పే కదా 2 నిమిషాలకి బోర్డు ఇస్తాందా
అడ్వర్టైజ్మెంట్ ఎంత ఖర్చు వచ్చేది నేనే స్పాన్సర్
ఎక్కడ కాదు ఫోన్ నెమ్మదిగా ఉంటూ ఫోన్ పెట్టాను సో యూ కీప్ యువర్ ఫోన్
వీడియో కృషి అవి అంతా కొట్టుకుని ఒక అట్లే కోవాలి నడుస్తున్నాయి నన్ను ఇలా ఉంది అయ్యో అమ్మ చేసిస్తాలే ఎంత రేటు అయిపోతే అయిపోయినాయి నేను దాకా జరిగినది అయిపోయింది
Megha, could you please mute yourself?
కూడా ಇಲ್ಲ ಸರಿ ಬೇಡ ಕೋವಾ
Megha, could you please mute yourself?
ಚಾಕ್ಲೇಟ್ ಇಲ್ಲ పోతాం
Okay. Start today's session. There are some technical issue because of that. Some parents were not muted, and that was creating a big trouble for everybody. Please make sure you all are muted. Session. Before we again get into new things, let's quickly what we did the other day. If you have any question, we can discuss those questions quickly because we have to cover a lot in today's class. My is breaking. Is it for only Manoj or for everybody? Great. Thank you so much. In the last class, we did basically went ahead to understand further in process testing. We understood ANOVA, we understood chi-square test, okay, and after that we understood correlation. Correlation is helpful, and finally understood regression technique. In addition, we ran one regression model. We input output. We understood what R square is. We understood why run the t-tests. We also understood for ANOVA in regression. Okay, that we did very thoroughly. And we also understood by the end of the session what is multicollinearity and how to graph with multicollinearity. So this is what we discussed the other day, and by session we got into the discussion of machine learning, what machine learning, and what are the different forms of machine learning. I mean to say, what is learning and what is unsupervised learning. So we got into those kind of discussions. If you have any specific question, please ask me. Plus, let me share a couple of files. Some people ask me to discuss some topics which I generally don't take up, like dummy creation of dummy variable and all, because things are very easy. Simple ask me, so uh, the 3 files and import these 3 files. Select recipient option. So and these files and upload these files into environment very quickly, and we will continue our discussion from where we left the other day. So files, I given you one file of house case, house prices. I have added another variable into this, so you better use these files. I'm using these 3 files for today's discussion. Please download these 3 files and upload these files into your SAS environment. Just a minute. That is not done. What is the problem, Brenda, you are facing? Just a moment. I'll take the presenters very quickly to help screen so that I can help you. Yeah. What is the problem then? Okay. What problem you are facing then? Okay. So please give me the presenter access back. Okay. So we were discussing about any other question? Okay. Expecting you all to uh, upload these all files into your SAS environment that we don't lose of time. I discussed about machine learning basically. I to explain supervised and unsupervised learning. I like to give you some examples from real life scenarios. Explain what unsupervised learning is and what is supervised learning. For the example of human being, we try to club, but we try to bucketize anything on our previous experiences, previous examples, then supervised learning. But if looking for the past records, we are not looking for the past experiences, we are only looking for the pattern in the existing data, then that's called unsupervised learning. For supervised learning, I gave you the example. So that's supervised learning. In unsupervised learning, on pattern in the existing data. Pattern, this seems to be a very broad term. This seems to be a very vague term. Pattern, I mean to say, we look at some uh, parameter. We pattern of some parameter. That pattern might be distance. That pattern might be some other statistical parameter. People who are into R as well, they'll be learning assumption rules, market basket analysis, which is used in recommendation engines as well. Recommendation engines, I must have explained to you in the first class, what Amazon does to recommend you the products, what Netflix does to recommend you the movies. Okay, so how these recommendation engines work, that is also a part of unsupervised learning. In learning, example of food analytics. Okay. In supervised learning, we'll be learning logistic regression. That will be the part of supervised learning. In unsupervised learning, we'll be learning cluster analysis. In today's class, what we do in cluster analysis. What is a cluster analysis? So we have done what cluster analysis is all about. Then we'll be coming back to regression and then logistic regression and all. What do you want me to repeat? Supervised learning, we take the rest of the past data, past experiences, and then we categorize the present data. That is what we do in supervised learning. In unsupervised learning, we present data, whatever data we have at hand, and then we look at the pattern in the existing data. That is what we do in supervised and in unsupervised learning. Machine learning. Okay. Now let's come to cluster analysis. What is cluster analysis? What we do in cluster analysis? Right. Yes, you are right. I told you cluster analysis is an example of unsupervised learning. So learning, I did this thing in the last session. Two examples for both. Have you visited what we did last class? So please come to class before you visit the last lecture. Okay, helpful for you as well as for rest of the class. Analysis, yes, we see some very good responses. It is of the segregation of data points by the characteristics. Residual group of same features. So let's discuss about it. What is a cluster analysis? Examples of cluster analysis, and that will serve for the examples of unsupervised learning as well. So Krishna, you again have one chance to get some good examples of unsupervised learning, because cluster analysis is unsupervised learning only. Okay, so you have another. In marketing, so I have always been into marketing strategy. So I have been doing the analytics for marketing strategies only. marketing strategy can be by three steps only. TP, T targeting, and then positioning. That is what you do in marketing strategies. First of all, what you do, you recognize segments in the market. Since mean to say you the objects in such a way that in one segment you maximum homogeneity. You have same kind of people. You have you have objects who have similar kind of behavior, who have similar kind of preferences, who have similar kind of price. Okay, and different heterogeneous as genus as possible. That is the difference between different clusters. So are also termed as clusters in statistical terms. Once you have recognized segments, those segments with the relevant product and the services, because this era is all about customization. Every customer wants a, a treatment. This about that. Okay. So we can customize our services, our product according to these needs. It will be very difficult for us. Positioning. So very difficult for us to target each and every customer, because there are millions and millions of your target customers. You will not be able to cater to each and everybody's need. So that is the reason you create the segments, so that you can cater to the needs of those segments in some way. Okay, you can go for the customization. This is all about marketing. Create the segments and then you target those segments. Positioning is position is something which is related to the branding more. It is about creating the image of your brand, of your product or service in the mind of the customer. Share of money and your share of heart in the customer. So I'll be talking much about marketing, but this is the gist of any marketing strategy. You got it, Brenda? So create the image of your product, of your brand, of your in the mind of the customer. That's about positioning. Yes, specific customers. Perfect. Positioning. So basically, this is about marketing strategy. Now, let's talk about direct marketing campaigns. So that tailoring your services and your products according to those segments. You need to run the campaigns. People with the advertisement. You want people with relevant emails. You commonsensical to with the advertisement of those products and services which are not pertinent to that customer, that prospect. Like to reach your prospects, your customers with relevant advertisement, so that brand remain relevant in the mind of the customers, in the mind of the prospects. So do you get a list of a million customers, a million prospects? That list and do cater different segments accordingly. That is what you do in direct marketing campaigns. Example of clustering analysis. Uh, Hence, you are just clustering. I'll do one example in as well. So to diversify your investments, it's different companies. It's difficult for you are actually into some investment bankingization. It's very difficult for you to get each and every company. Okay, uh, uh, when clusters of the companies take up their financial ratios, their capitalization, their revenue, and all as a statistics, and according to those financial characteristics, you can club different in clusters, and then you can decide about investments into those clusters. That'd be a better way. Okay, so about clustering. Clustering can be of many types. I might have explained to you in first class that clustering can be hierarchical clustering, it can be k-mean clustering, and it can be DB scan clustering. Taking you through the algorithms of hierarchical clustering and k-mean clustering, DB scan clustering is one step ahead, and I discuss DB scan clustering in my R classes, which is used for uh, for clustering the image, the videos, completely unstructured data. Okay, so let's start off our discussion with hierarchical clustering. How hierarchical clustering works. Make the things very easy for you. I have created this Excel, which will help you to uh, grab the concept of analysis very well. Okay. Hierarchical clustering is concerned, we can use hierarchical clustering, but it's no more very prevalent in the industry because the reason of time. Some inherent with hierarchical clustering, time to get executed, and the output is produced in the form of this diagram. Difficult to interpret if you have huge amount of data. Okay, this is a very preliminary way of creating the clusters, which people used to go for when there used to be small amounts of data, but nowadays the has increased to such big levels. People don't go for hierarchical clustering. They said for k-mean clustering. Okay, but it's important to understand what happens inside the algorithm of hierarchical clustering as well. So we have some idea of the says we have a feel of it. Okay, questions so far? Okay. To make things easier, I have kept here only these four, sorry, observations. 5 observations, 5 records, I should say. These 5 records will try to create the clusters of these records. Okay. Variables V and V2. One is 1 and V2 is 1. So if you want to plot it, you can plot it very easily on this argand plane. XY plane. This is record 1. Record 1. Have 2, 1. This is record 2. Okay. So, comma 5. This is record 3. For comma 7. This is 4. And this is record 5. We have plotted 5 records like this. Plotting these records on the Argand plane, try to see pattern. What do you mean by pattern here? I told you at the start that pattern is a very broad term. We need to find the parameter and look at the pattern. So parameter around which we look at the pattern is distance between data points. Clustering algorithm, whatever clustering algorithm you are using, the point is the distance between the data points. Clustering algorithm tells you that between the data points XU, how closely the behavior of those data points are related with each other. If they are closely situated, if the 2 data points is high, it means that preferences, the priorities, the behavior of those 2 data points are likely to be very similar. High proximity implies high similarity. In proximity implies high similarity between the 2 data points. The 2 data points are very closely situated in the Argand plane. Algorithm simply tells these 2 data points have very high possibility of similar behavior. So if proximity between these 2 data points is high, they exhibit similar kind of behavior. That is what is by your clustering algorithm. Let use this particular bottom line and then try to understand how clusters are created. This step in hierarchical clustering create this kind of matrix. You would see points lying on the rows, same data points are lying on the columns as well. So 2, 3, 4, 5 in the 1, 2, 3, 4, 5 in the rows. And we find out the distance between data points. So this is representing the distance between 1 and 1. This 1 is representing the distance between 2 and 1. This 5 is representing the distance between 3 and 1. This is the distance between 4 and 1. This we find out the distance between all pairs. Or we will see the same kind of values, because distance between 2 and 1 will be same as the distance between 1 and 2. No point filling these values as well. Finding out these distance values between all pairs, we at that distance the distance values will calculate, and after that we get the minimum distance value 1.0. If you would see, this is the minimum distance value. Okay. Minimum distance value, what we do, we have those 2 data points together into one cluster. cluster. So the distance between 1 and 2 is found to be minimum. So what we'll do in the next step, we will merge 1 and 2 into cluster A. Create one cluster. Cluster A we'll call that. And in 2 and 1, now that uh, will place that 1 and 2 will be replaced by cluster A. So these two will be clubbed together in the next step, and this will be called as cluster A. And you have cluster A 3, 4, and 5. Cluster 4 and 5. And you will distance between different points. Now find out the distance between A and 3, A and 4, A and 5. Okay, find out. Look at the minimum distance. So 4 and 5. The between 4 and 5 is minimum. That is 2. We together into another cluster B. And then again, we find out the distance between different data points. Okay, the process will keep going on and on until we get the number of clusters. Now I take up the questions here because I don't want to move to where it will be difficult for me to come back. Wait. Right. How to arrive at the distance in the above matrix? Okay, so we Euclidean distance methodology to arrive at the distance values. Euclidean distance methodology is you must have learned this in mathematics long time back. Let me quickly tell you what Euclidean distance methodology is. Just a moment, my system got hanged. A moment. Select any cell. Yeah. So what we do in Euclidean distance, uh, that's not very much required, but let me help you with that. Just a moment. Let me just give me some problem. Tool. Two numbers x1, two data points x1, y1, and x2, y2. Between these two would be the root of x2 y2 square. Things are done automatically, so you need not to worry about this. That's also calculated these distance values. I have some more questions. Mm. How can we find the distance between cluster A and 3 and 4? Okay, I'll come to that. So Prana, you got the answer to your question? Lizzie, I did not understand from the scatter plot representation. Optic means, okay, two questions now. Excel. Excel is restarting. Yeah. Okay. Yes, how we calculated distances is plot. Razika was not able to understand the scatter plot. So plot is only telling you the distances, how these two are related, how these two are placed. So I am clubbing these together in the first step. This one and this is two. Okay. Two are clubbed together into cluster A because between 1 and 2 was the minimum. Was the distance that was equal to 1. The set 4 and 5 were clubbed together. 7, 5, 7. So the distance between two, these two clubbed together in the next step. You get Razika? We missed 7, 7 and 5, 7. Where did I miss that? 7, 7. Correct? 7, 7 is your data point 4. 5 is your data point 5. Okay. The third step, people were asking about how calculated the distance between A and 3, A and 4, A and 5. Okay. To calculate this distance, we again have methodologies. Okay. We can for single linkage, we can go for complete linkage, we can go for linkage. I'll tell you. These all things are done by the tool only. Here, a diagram has been explained. So, distance between these two clusters can be calculated connected by finding out the distance between which are at distance. This way of finding out the distance between the cluster is called as single linkage method of finding out the distance between two clusters. In complete linkage method, what we do, we find out the distance between which are distance from each other, done in complete linkage methodology. In the linkage methodology, we found the distance with all the data points. We find out all the pairs. Okay, find out the distance between all pairs, and then finally we average out the distance. Okay, the average linkage. The first is centroid linkage, and we find out the centroid of both the clusters, and then we find out the distance between the centroid. So there are methodologies to find out the distance between two clusters. So I used one of the methodology called single linkage method to compute the distance between clusters. I'll look up the last optimized clusters mean. Cluster, I mean to say, hierarchical clustering starts from all the data points and finally it converges to one center. Now up to you to decide how many clusters you want to create. So with that, see, you can create here 3 clusters and you can create 2 clusters as well. It is again up to you on your business requirement as well. Suppose you want to create a product for different types of segments. Let's take the example of biscuits. So you are an FMCG company and a product. So packages you create for different types of people, preferences according to their buying behavior, according to their purpose. So for areas, you want to make packet very small size because people, you from your research that they have the habit of buying the biscuits on daily basis. So you would create a smaller pack for rural areas. Again, you would make better for areas and a bigger packet for urban areas. Again, you might like to create small packets. So basically, you segments, and then according to those segments, you want to create the packages, and you also have your limitations, your business constraints. Suppose you have planned to create 3 types of packages. Obviously, you would like to see 3 types of segments. So you already have in your mind that you want to create 3 clusters. So that's what I mean to say optimized number of clusters. Any question? Good. So we have understood what we do in clustering. So after doing hierarchical clustering, you get this kind of tree diagram. This is again produced by the tool only, and this is as dendrogram. Very preliminary way, because a lot of time, the kind of algorithm it uses, it go for multiple iterations. You see here, multiple iterations are done. We get to optimize number of clusters. So generally, we don't use it when we have huge amount of data. The second type which we mostly go for is k-mean clustering. Some of you might have heard about this name as well. Okay, let's understand the methodology, the algorithm which behind k-mean clustering. In k, what we do to a number of iterations, the understanding of the number of clusters which we want to create. So the number of clusters here in case of a k-mean clustering. So suppose we need to create 2 clusters here. So randomly assign the cluster number. So let's see what we have done here. That will explain you the everything. So 5 data points are again plotted in this. Then I've done without the centroid of cluster A. A we have taken B2, B3 and B4. B3 and B4. These 2, 3 we have clubbed into cluster. And 2 we have into another cluster that we have done randomly. Okay. 3 clubbed into cluster and these 2 have been clubbed into another cluster. And we found out the centroid of the 2 clusters, cluster A and cluster B. Okay, it's randomly find the clusters here to data points. For these 3 data points, we have assigned cluster. For these 2 data points, we have assigned cluster B. Seeding, this is called. We have created 2 seeds here. So we have created 2 clusters here. We have done randomly. This what we go matrix in we find out the distance between each item cluster A. I mean to say each centroid of cluster A. Item 1, 1 in item and centroid A is calculated. The distance between item 2 and cluster A has been calculated. Item 3 and cluster A has been calculated. Item 4 and cluster A has been calculated. Item 5 and cluster A has been calculated. These distances again were calculated cluster B as well. Then in lies for item 1. The distance of item 1 with cluster 1 of item 1 with cluster A is 1.89 and distance of item 1 with cluster B is 7.81. This is rising for me. Why rising for me? Because so this is 1. This is 1. So this distance is saying that the distance between distance D1 D1 and this if 1 belongs to cluster 1, the of one from the of cluster A should be the of one from the centroid of cluster B, which here is strange for me. Any who could not understand this point? Okay, so the last point I mentioned that the distance, ideally, if assigned the clusters in this way, the distance in I1 and the of cluster A, then that between 1 and the centroid of cluster B, because 1 belongs to cluster A. Centroid of cluster A should be the least. Should be its distance from any centroid, which is here. So no problem here. For well, this is existing here. But item 3, if you look at, this is item 3. The distance is telling you this distance D1, call it 3, 3, and let's 4 or D3 dash. Distance of 3 from the center of A, that of 3 with cluster A, its distance from cluster B. This is which, because we have assigned cluster A to third item. So what next step? Item 3 cluster B, and 1 and 2 would be remain cluster A. Again, the distances are added after recomputation of the centroids, and will keep iterating. Okay, happens. Yes, Sanjuna, that is what has been done. 3 have been moved to cluster B. Any question? Wonderful. Clustering gets repeated. Yeah, I want each cluster to least differences within their. Says yes, you are right. Perfectly put. How the reclustering? So clustering go over multiple iterations that you can see in the output, and that has nothing to do. Mean clustering is a very fast procedure, and because of that, we use first class to and get the cluster. or scaling the number of iterations. SAS will do everything on its own. It is very much automated. I only want you to understand how it happens between screens. Again, you will, if you are doing it manually, you will require to recompute the threads and distance between each term, and the threads will be calculated, and the same procedure will uh, it. Haven't you seen the difference between the two industry? First, you're finding out the minimum distance, and then you club clusters together. So the algorithm is completely different between the two. In clustering, you use a different algorithm. In k-mean clustering, you use a different algorithm. That you have seen. Second reference is hierarchical clustering. You choose the number of clusters. It will suggest the number of clusters as well in between, which is not there in k-mean clustering. Practical, you always have the understanding of the number of clusters you want to create. So, k-mean clustering, you need to have the understanding of the number of clusters you want to create. In clustering is the process of k-mean clustering is very fast. So, I told you. In process, we merge the importance. I told hierarchical clustering does not work very well when you have huge amount of data sets. So use hierarchical clustering. Uh, yes, if you have here, you have only some 1 million observations. What do you do with hierarchical clustering? You will not do recognize anything. Yes, less than 50. Uh, Maybe that as well if you don't have any option. But we have some awesome cluster techniques. Why would I go for hierarchical then? Question? Yeah, we always came in clustering. In we generally use k-mean clustering only. Okay, let's go ahead and in SAS, please import a set very quickly. Okay, import from our data. Just a moment. Quickly and comma. Leave it in work. Make the so I written the code this time so that we don't waste a lot of time Let's give it a name, pharma. You you change this address only. I reiterate. How can you find this address? This file, go to properties, and then this address. And click the data file option. Instead of this, you can put your address. Done. Soumya, I'll send you. So that document which you created and shared with everybody last time, something very nice. And I was wondering if Soumya can create a doc within the class. Why can't everybody? This is something awesome, wonderful effort, and the most appreciable thing is that you shared with everybody. Everybody's help. We all. Okay, so you people must have imported the file so far. Good. So this file, if you look at, there are some companies mentioned here. Okay. And symbols are mentioned here. Symbols are also called as tickets. I want import pharma data. Pharmaceutical companies and financial data given here. Tickets. I believe some people who are the experts in finance. When you register your company in the stock exchange, sure. Yeah, you are right. Get uh, one ID for your company. That is your ticker. I'm just called these names intentionally so that if you get hear those things, you don't get strange. So once you import this data, I'll, uh, I'll understand what we want to do with this data. So basically, we want to create the clusters of these companies. So it might not be. You need to search companies in New York Stock Exchange or BSE or NSE. But just uh, just like I want you to know about this. So capitalization, beta, P ratio, ROA, our leverage, revenue growth, net profit margin. Okay, the new variables you have in your data. To these numeric variables, you want to variables, I should be calling them as financial parameters, financial ratios. According to those financial parameters, we want to create the clusters. We want to know the companies. Uh, ONPE. That's a different discussion. I don't want to get into financial discussions here, but you are thinking in those terms. So yeah, that's let's so we clusters around all the variables. Okay, and go clustering. We need to look at something. Uh, different numeric variables here are different uh, well. Here, revenue growth percentage. You have okay structured, but you have different variables uh, in days. Okay, margin dollars. There are some percentages. Okay, so about this situation, and you are looking at these financial parameters in marketing analytics, because I'm not a finance guy, to be very honest. Yes, I use some financial parameters. I work for a financial institute, but uh, my have not been into finance. They have been into statistics, uh, into marketing. Statistics and marketing background I have. Brenda. So look at any marketing data as well. Suppose you need to create the clusters of different uh, people according to their demographics. Good to have Brenda. So I was talking about marketing analytics, and if you want to, yes, you can call it as to create the clusters, the segment of different prospects according to the demographics. The demographic parameters, you would see age value, you would see the salary, okay, you their uh, uh, you would many parameters very different from each other. So A B in years, in dollar. Go about dealing with different types of variables, because here the example which I gave you earlier, example, I these two variables are of same unit, but if they're not of same unit, how would I go about that? Ultimately, you are finding out the distance between variables with the data points. You calculate the distance yeah, you are all right to get all the variables into the common unit. Okay, to make them into a common unit, what we do, we standardize these variables. Some people term it as scaling the variables. Some people term it as normalizing the variables. And people use different kind of terminologies, but ultimately what they do, they subtract. What they do, they subtract each every number or data points of the variable by its mm, it is mediation. This is done in every point. This is called as Z. We all hop. Can you realize the distance? But how would this be able to get rid of that issue of its? One unit of each variable now. So you are right. Now, all as unitless. Suppose you are market capitalization. So capitalization value minus the area of market capitalization, it will be will again be in dollars. So would be, do you get me? Okay. So basically, all bills would become here, and that will help us in out the distance between the points and then putting into different clusters. But the unit of standard deviation, that what this dollars, what then for Z? Less. Okay. This is basically a proportion, which is a unitless thing. But how would you go about that? Let's do that. So we'll standard here. We can use standard because that will require the variables, we can learn here another procedural step for contents. About your data set, to the information about the variables and all. So you can mention the data. Data is equal to pharma and run. So it gives you. See, it gives you member type, engine, created, last modified, blah blah blah. Too many things it gives you. You give a list of variables you have, the type, length, format, in format, many things it gives you. I'll add something here to make wanted find the variables. We get short here and it will give you the list of all the variables by spaces. Something required to mention the name of the variables is many. That's why I used this. But I already have the code written here to make the things faster for you, not to go for things. So all the numeric variables I have kept here. And paste your code so that you can also run. Let me use code as well in the chat box. Data dimension, you want mean as 0, standard deviation as 1. Will be saved in for standardized, where you will mention all the variables. Variables have been standardized. Once standardized the variables, now you can go for string algorithm, which is proc fast class. So proc fast class I believe else. Yeah, please use this one. here the standardized data. Suppose I want to create 4 from the subjective understanding. I view the final profiling. There, anybody question? Who all are okay? Yeah, that's that I pasted here another code and then cluster I believe I wrote. Let code again. We are facing. How can I help you? The data. This code to make it faster. Set all the codes. Have in the output. In output, you would see new variable called cluster has been created. Another variable is distance which has been created. So this cluster is actually telling you uniqueness of record 1. So 1 belongs to cluster 2, record 2 belongs to cluster 1, record 3 belongs to cluster 3, record 4 belongs to cluster 2. 4 clusters have been created and distributed. All the points are clubbed together in this way. Anybody in the data set? We fit into the results. These two last columns were run talk first class. You can use these codes as it is. The name of the file which is saved in file setting at pointer in 100. Okay. Access quickly and out. Please please share quickly so that we can sort it out. Okay. Double click on farmer so that I get it. Farmer. Great. Now go to program. Paste the code here which you can use. Please chat box. Yeah. Yeah. Go to you have here. Select everything. Put press 3. Good. The bit. And paste the code in the chat box. Code and in your code window and run it. Give. Okay. Let's understand the output. Are you all ready? Any trouble? Good. So let's output uh, initial seed and then initial seed this kind of summary then statistics variables. Finally, you should be interested in is last bit, cluster means and cluster standard deviation. We into algorithm again. We have understood the whole algorithm. Look at the cluster means and cluster standard deviation because the majority of the time goes into cluster profiling. Once you will create the cluster, you need to define your cluster, what your cluster is containing. So look at market cap for cluster 1. Mean market cap and the mean standard deviation. So define the clusters according to the values and the deviation. Cluster 1 has a market cap of this and deviation of this. Here you can see these values are coming out to negative because it is still considering those Z statistic values. Statistic values you can convert back to the original values because you already have the information about the mean and the standard deviation. Okay, so you can convert these values back, that big deal, and then profile your clusters. Over 3, it is blank values above or invalid for correlated variables. So after summary here, there are observations you have in cluster 1, 2 observations in cluster 2, 1 observation in cluster 3, and 7 observations in cluster 4. That's why you are getting these standard deviations as blank values. So basically, you have to perform 2 steps. In the first step, to normalize the data, and in the second step, you need to run this clustering algorithm. That is what you need to do. The final step is very important, where you profile your clusters, create the cluster profiles. You what clusters are all, and it comes into subjective understanding into your uh, understanding. I'll give you the example. You will, if you have understanding, if you know the financial parameters, the financial ratios, you can easily find out what cluster 1 is containing, what type of companies cluster A has. Okay. Let me give the example which you may be able to relate better. Actually, at the last moment I picked up this data. Uh, I'll give other data sets as well, and in your projects as well. There are some other data sets as well which might be very close to your understanding, like marketing data you might get. Marketing data, you can see the clusters, and you can look at the cluster profile like this. The average age, you will know average age of this cluster of segment, you can call as a segment as well, is 25 years. Most of these people belong to rural area, so you see what type of area they are. Their income, the income is like this, and the standard deviation of the income is like this. Am I not able? Yeah. Okay. So then, out of this, most time goes into cluster profiling. There will be a lot of time which will go into argument. You would require to take out the outliers, implement values for mean values, so that also consume a lot of time. Okay, so that's about the cluster analysis which I wanted to discuss here. A lot of analysis in clustering technique will be done in our classes as well. So that so there are things which are yet to be taught, but they are left for our classes. So we divided the course in this way. The next step is your science using R. You can see the out data in which the object given the belongs of different clusters. So you can see the observation 1 record is 2. Okay, observation 2 record 2 has been assigned to cluster 1. Okay, then any variable is of categorical nature. Niranjan, let me tell you, there are some tools which will pick up the categorical variables as it is. But there are many tools which might not pick. So I talk in terms of many tools. In SAS as well, you might need to convert those categories into numeric values. So you can use if then else statement and convert those categorical variables, those categories into numeric values. Then it will be able to help you. You meet variables here in clustering. Niranjan, so those are three categories. You give them some numeric values. If the suppose x has value a, then 1. A variable, yes, back to the original values would become 1, 2, and 3, but you can convert back into the original values as well. And by use 1 and 2, 1, 2, and 3 as well, you all know that what the variable values can have. Okay. What I do in these type of scenarios, let me share my experience here. So this is something which I'll tell you. Uh, 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 a cluster analysis so that to it out. What I would do if I have a categorical variable, suppose two categorical variables I have, what I'll do, suppose you have different departments, okay? Do for different departments. So I'll do at level by finding out the data points for different departments, for different regions, for different relations. But as well, you will be able to figure out. I'm making K clustering I have not used. I have DB scan clustering though, but K media clustering I have not used. Uh, in our course, yes, it is DB scan. DB scan. I'll come back to you. Let me Krishna's question, then I'll come back to you. Variables in each row, group them as clusters. It is around based on the distance between each row, between records for variables. We group them into clusters. Krishna? So group different rows in the Brenda. You look at the last two minutes in which we define this for market cap as this value of mean and this of standard deviation. Standard deviation because 3 is only one record. So 3 has only one record. Only one record has been assigned to cluster 3. And they define your clusters. This is what I say. algorithm should tell me how many clusters are formed in the data. Uh, as well, you can go for multiple iterations. Like cluster 3 has only one data point. Instead of creating four clusters, maybe you can go for three clusters only. But the result, it would also show you uh, what values you are putting into one cluster. You can pick up one sample. So it's the IT process. And let me tell you, clustering is something on mean a standard deviation is considered here. Otherwise, it is all about pattern recognition. It is your play data mining. So you result, and then again you will come back to the code number of clusters you want to create. So I can forth. So in four, I would here we decide about the number of clusters. Four, you can have only one is there in cluster three. So instead of four, I have not changed it to three. It is up to you. You go back and forth and see what you are getting. Then your business requirement, how many clusters you want to see. If you have suppose created three packages, okay, uh, I think triple C, pseudo, F stat. No, 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 no. In K clustering, these will not tell you. Yes, in hierarchical clustering, you count the number of clusters for sure. In clustering, this is the prerequisite. Prerequisite that you should know the of clusters. Of hierarchical clustering, clusters. Basic algorithm here is that you already number of clusters, and according to that, you create the initial seeds. Since and get the number of clusters. Yes, algorithm we discussed it at length, but back to you. But in clustering, you decide the number of clusters because then here is happening. Okay. The problem with hierarchical clustering is it is very slow. So what you can do uh, a random sample you can create a very small sample and then maybe you can try out that sample how many clusters are being created from otherwise hierarchical clustering would take a huge amount of time and how you will be able to figure out the number of clusters you would look at this dendrogram it was cluster profiling but uh, how you to figure out you have to use your business essentially you have to use your business requirement only. If you have created four types of packages, you would look four clusters from your set. Imagine if you have one clumsy the diagram will become. Okay. Proc again, hierarchical clustering only. This is something which you will from hierarchical clustering, and from hierarchical clustering you are finding out the number of clusters. Yeah, but that is you that hierarchical clustering, which is very time consuming. So say that, but practically uh, you read number of clusters and then you use k-mean. Okay. I was asking some. No, it was. It was. Any rule if clusters are more profiling will be good? No, it's very subjective. Profiling is something very subjective. So sometimes you get very weird clusters as well. Then you get different values of those different variables. You have outliers or not, so you go for different treatments. But it is very subjective. Because of that, you go back and forth. Okay. And able to show how the cluster profiling is done. Present to the customers. I have one cluster profile. I can share my experience with you since I have 2 minutes for the break. So what? So cluster analysis to most effective marketing channel. Really, that project was about SNS marketing channels. Discussing with you. So basically, uh, uh, exists technique organization worldwide by using random marketing channels. So they are marketing channels and they used very easily or using feelings. Actually, calling a lot of wrong spends. Always get a very little budget, small budget. So, even 1%. Those people who are into finance and who understand how the budgets are allocated to different departments, uh, the budget is 1%, 1.3%, not more than that. It is very small. Budget, uh, you just afford to spend frivolously. Okay, so according to different opportunities, so here we have prospects, then deals. Okay, location, market cap, other financial ratios of the company. Okay, so we are looking for inside out as well as outside in parameters, and this is something you always need to consider. Only I'm considering till now, upon different other parameters for the I found out the cluster for different, so different industries, explaining to Niranjan, I had different industries. So for each industry, I ran clustering algorithm to make a very simple. So financial services industry, suppose I created in one, I found that the image D size is around $10 million. Companies we are looking at, they are falling in these companies. Can some markup, okay? Can look at the location. Suppose the location is US. So this is something cluster profiling for cluster can be defined in this way that it has the prospects, the opportunities size around 10 million. You can or the range, you can find out the minimum value, maximum value, those kind of things you can do. So you have the data with you. The most of the of mid-size, they all companies are located in US. This is main cluster one. These events or these marketing channels you should go. That is was done in that project. Getting the feel of it, Chaitanya. As far as traveling is concerned, you can look at this here now. Cluster and then find out, say, proc means it is equal to mean minimum maximum. Okay, you can use variables. We have run, we have proc means. Yeah, what you can do, uh, clusters, since you already merge, so you can merge it with the original data and then play around. So help you in profiling. So having you by default the of mean and standard deviation. You can get to some other statistical parameters, descriptive statistical parameters, if you want, using proc means. So in 10 million, that is other events, etc. Yes. So it is considerably less than 10 million. So I create another clusters as well. Two. So clusters were defined. So it were defined, and any new opportunity is coming, we will match that new opportunity with the existing clusters. According to that, we will decide about the type of marketing channel we would be using. So we the types of clusters from data. Any opportunity coming up, we will match that new opportunity with the existing cluster, and we will decide about the marketing channel. Okay, in midway mark, let's break minutes. We'll come back and learn something wonderful. A very interesting technique called logistic regression. Okay. After logistic regression, with whatever were left in regression, linear regression as well. Okay. So, take 10 minutes break and come back quickly. Uh, just a moment. Change the cust. Now you have all clusters. You can your file. So it's not about only content of z score to the original values. You can the mean value. You have the standard deviation. The formula that z is equal to x minus mu by sigma. You can easily convert back to the original values. But you need not to do that. You can merge these cluster with the original data. Around. So let's break here for 10 minutes and quick back. session? From everybody who all are back. Thank you. So now we are going to learn something very important. One of the of supervised learning as well as logistic regression. We of regression also have some very good understanding of how regression is done. Okay. Now let's come to logistic regression and see logistic regression helps us with. So regression basically helps you when oh. Moment. Freezed. Just give regression basically is used. We have dichotomous variable. We have a dependent variable of nature. I gave you this example of a fraud analytics. In fact, I gave you this example that uh, categorized either into fraud or into non-fraud, a defaulter versus non-defaulter. So you may have two types of values. One can keep for defaulter, you can keep for Excel. Working. Let me close my Excel completely. Working now. So you types of values for response variable. Yeah, so binary nature here of dependent variable, I mean to say the dependent variable can assume only two values. It can have one or it can have one or two. Okay, only two values it can assume to say. One data set uh, just create, I believe. If you will import that data set, let me help you import that. Let's use the same code so that we don't have to struggle with the coding part at least. I'm pasting change the address. Please just before you run. So I had this code, sorry, this file, import. Good. Okay. Done? Can we start the discussion? Okay. File, you have a variable called default. This variable is the dependent variable here. And only two values, 0 or 1. Okay. Others are duration, amount, installment, residence, age, cards, level. Okay. So it's of variables you have here. The scenario, finding out uh, the regression model. Still one variable make the discussion easier. Let's variable. So I'm here as variable and variable I'm giving 1 or 0. So you will see 0 for other page you will see 1. So there are some zeros, there are some ones. We will be able to find a straight line. Line in this particular scenario doesn't make sense. We need to devise something else. because is a continuous variable. We here a dichotomous variable which have either 1 or 0 as value. Okay. Okay. Making sense. In this particular scenario, when you have a dichotomous variable, when you have a, variable, it is very difficult or close to impossible to find out a line. Yeah, you can have only two values. So out a line is something nonsense. Finding out a line, what we do here in this particular scenario, we use the probability value. So I'll show one chart which will define the relationship between these variables. So I'm making up age right now. Let's call it A. I am plotting is called as sigmoid curve. Okay, and this curve can be represented in this way: P is equal to e power a e raised to the power a. So the value of probability value lies between 1 and 0. So it's 1 and it can't be less than 0 as well. So look at these values. If a will to 0, what it will be a big number, what will be the probability? You can see these things. Manipulation into this. Age will age here. So is equal to e power a divided by 1 plus e power a. Let's divide numerator and denominator by e raised to the power a. So it will become 1 divided by 1 plus e power minus a. Okay. Cross multiply. So 1 e raised to the power minus a e is equal to 1 value of a. 1 by p 1 equal to e to the power a, like uh, lights minus a on e 1 p, sorry, ln net log p 1 minus p. Full equation here. I'll why I am calling it as wonderful. Do you have any questions so far? If you're not in anything, so only one variable. We considered only one variable. Suppose multiple variables. So in A, what we can replace A by a linear combination of those. A can be replaced by beta naught. This is what we did in linear regression as well. Beta 2 x2 is equal to ln p by minus p. This equation is called as equation. Equation is called as limit equation, and the term which is within this ln is called as or. So basically what we have here in logic equation, we have here law of odds is to a combination of these variables. Okay, fx2 fx3, or let me put like this: beta naught plus beta 1 plus beta 2 x2 obtained this equation. I'm pretty excited. I said it's a wonderful equation. So can you tell me why I called it equation? Why there is so special about it? have any problem question here. The derivation is pretty straightforward. So derivation, because this derivation will help you to understand and interpret the output. The output of the logistic regression model will be difficult for you to interpret. Yeah, you are right. Able to connect the dots here. We ended off our discussion with this issue that when we have only binary values for the response variable, when we have the dichotomous dependent variable, it is for us to relationship between the independent variable. Now this can easily be done using this equation, because here of odds have been related to linear combination of variables. Yes, Niranjan, you are right. Which will allow you to run the regression model very much in the same way we ran regression model. Okay, we get into modeling and interpretation of the outputs. It's important for us to understand what is odds. What do we mean by odds? So what do we mean odds? So people who are who have gambled, uh, visited Los Angeles or the places where casinos and all, they must be aware about this term, ratio and all. What are odds? To X3 are different independent variables, Krishna. Yet to the likelihood, it is related to the chance. Let me be very explicit. What odds ratio is, I have already defined it in front of you. So it's the simply the of divided by probability of non-occurrence. Occurrence, probability of non-occurrence. I think might be very might not. So it is occurrence. It is equal to probability of occurrence, probability of non-occurrence. Very simple. I'll have examples to quickly understand this. So, want to find out the odds. It is the probabilities. No involved in that. In that. Odds. Suppose you want to find out the odds for head. Head can be found out by the probability of occurrence, means probability of head. If you are here, fine. Output might be head or might be tail. So 1 divided by 2 would be of head. Occurrence. What is the probability of non-occurrence? It would be 1 by 2. So be 1. Denote as well 1 is to 1. Okay. So the of only probabilities, not log. Okay. That log of odds, right? Like 8 salary income. Any just quickly out the odds just for or 1 or 2. uh, said honest dice. So I was saying a dice said 1, 4, 5, 6 you have on dice. It is unbiased. What or for 1 or 2. But I don't want to. We don't want to waste much time here. You are looking for 1 or 2. So one D, okay, d1 minus 1 by 3, 1 by I mean 0.3, 0.6. Okay, 1 by 2. Now yeah. So it will be 5. You are right. Okay. Ratio a ratio of 2 odds. So you see these kind of terminologies. So odds ratio is the odds. So this actually tells you the reason of occurrence and non-occurrence. So if you take the ratio of probability of occurrence to non-occurrence, it gives you 0.5. Is not about 50% chance. Is can will again be defined with the help of probability only. Chance is 1 by 3. It is the chance versus non-chances. What is the question? Okay. 0.5 odds in favor of head. This is term it as. Or also it is way there is 1 to two of heads. So as well, uh, if you people bet for the countries in football or in uh, cricket, you see these kind of technologies. So all in favor of India winning this match is 1-2. This is how we go about it. So example as well. So you should actually understand it in this way. It is the rate of something happening to not happening. Happening, thing not happening. Here, use the favorable condition, the probability of the favorable condition, and denominator, you thing the condition. So you don't have rest of the things. So in the case of head example, call it as there is 1-to-1 chance in uh, head toss of a coin in the toss of a fair coin. This is how you go about. Uh, to make it easier for you, so have one loaded coin and you have one fair coin. Okay. Odds ratio will to understand it better. So let's first of all clarify all the dots at this point. And it making sense now? So probability gives you what is the difference between probability and odds. So uh, so take it in this way: probability gives you the proportion, and also gives you the proportion. Both the terms, both the statistical parameters, give you the ratio. The ratio of fair outcome divide the total number of outcome. In odds, you would see rate win, favorable and unfavorable. This is of this, or if you'll find out the probability of 1 or 0, they divided by the total number of outcome. 2 by 6 or by 3. 1 is the number of favorable outcome, total number of outcome. But odds instead of probability, it 1 divided by 2. Obviously 1 divided by 1 by 3. So these be common, but look at these numbers, it is giving you favorable number of outcome divided by unfavorable number of outcome. It's about the total outcome. So giving you the ratios, but in odds you are getting the ratio of favorable number of outcome to unfavorable number of outcome. But in probability, using the ratio of favorable number of outcome to the total number of. So total contain favorable as well as unfavorable. The thing, if you understand it that way. So both have the same question: why it is used of the reason of getting a proportion, getting the comparison of versus another. Probability always talks about one. Uh, it taught both the sets. So if you are getting two teams, okay, so you the of one team versus another. So it not talk about only one thing. So here in case of probability, you see talk about the aspect, other side of the coin, about one particular set, and it's comparing with the whole universe. So we are going for all. These analogies are mostly used. Otherwise, you have to divide the probabilities and then get to this number. Better off in this way that it is directly giving you the comparison of what you want and what you don't want. It is that ratio directly. The second thing here, this mathematical formula comes out in such a way the it is taking up the law of odds. So interpret the output of logistic regression model. It's very important for us to understand what odds mean and then how to apply the odds. Okay, odds and default. Default, no default is how would you interpret? Okay, I'm to this. We have to discuss at length. Let you know here about the basic algorithm. What we use here in logistic regression. In regression, we square methodology. Case of logistic regression, use maximum likelihood approach. Maximum likelihood approach we use to find out different coefficients, how we go out that it is about to come. So likelihood function we find out and we maximize that likelihood function. Find out the coefficient of different variables. Okay, so let me quickly logistic regression model and take you through the output. Run Okay. So now let's to the details of what we have gotten in output. One. So to use model statement on the right hand side, left hand side, you keep the dependent variable. Equality, you mention all the independent variables you have. And on this, you will get this result. So, and one by one, each and everything. Uh, Getting into these kind of things, uh, just question before I get into these things. Or default versus non-default is coming out to be suppose zero point 0.6. Repeat that. So default versus default. You are default and not default. This is not default. Default common default. Uh, uh, Common non default. And you have people. ESL can be default or non default. So this Q 0.6 first of all. Okay. Because considering here everything. Am I making values for this either or non default? So find every here will not. So out. So finding out odds for default. Uh, there are two events in your sample space. One and one two a probability. But you will see it is not equal. Have been equal, things would have been very easy for us. We would have gone for logistic regression. But suppose the probabilities are equal. They will 1 by 2 divided by 1 minus 1 by 2. You get it? So here you should consider only either default or non-default. Okay, so let's come to the result we have in this result. As it is telling you response variable, it is giving you as default number of response levels are 2. Binary logit mode or here is a fixed scoring. Other tools like in Stata you have another optimization technique, which is I forgot that name. You can search it on Google. In Standard, they use a different technique, but they still use the same kind of result. A number of response profile. You have 700 observations with zero value of default, and there are 300 observations which has default value as 1. Probability equal to 0. So whatever probability values will be calculated, that calculated for 0 to 0, which is taken by default by SAS. If you want to change it and you get the values for 1, you get this option descending in the first line. Everybody, build is 0 here. In lab scenarios, probably we most of the time 1. Suppose if we are looking for the probability to default, we give default as 1. So then something which we have the habit of doing. Instead of default value, here go that we are very much used to of, which we are very much which is very much convenient for us, which is more conditional. So instead of using this, we can use descending option in the first line. And anybody any question in this? Let's code here. Oh, latest one. So at the output now, this being probability modeled is default is equal to 1. Probability modeled is default is equal to 1. Now be getting the probabilities to 1. Probability default basically you will get. So far, okay. Come to uh, convergence state. What this all about? Conclusion from this chat is final conclusion from this stat 01. 300 observations where the value of default is 1. There are 700 observations where the default value is 0. If you look at it, is only telling you data set. 1 default, 0 means non-default. Yeah, the payment. Got it? This point, if you're descending, then we need to read 0 means default. No, no. You won't change the convention. If you have kept 1 for and default at the start, after running the regression model, you'll not change. Yes, I like to use this option descending. Then you can at the start, at the outset only, you can impute uh, default and uh, instead of non-default. Here is descriptive. What do you mean by descriptive? No, no. What occurs is 0.7. No, 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 no. You will not calculate the probability like that. These things are not equally likely. You have parameters affecting this. Okay. We find where default if there is new obs. If you default if there is a new obs that our objective is. Objective is to predict for the new customer. So you get a new customer and you want to predict the probability of his being a default customer. You get out using logistic regression. That is in all otherwise learning techniques. Okay. So with us. Just a moment. Create logistic regression model because we already know the values of default here. Okay. So put some other new customer and you know the age, you know the number of cards, residence, installment and all, and you can then model to find out the probability to default. Am I right? So this data serve the purpose past records. This is these past records. From these past records, you will build the model. You will create that function. Okay. That function, you find out the value of default for new customers. Yes, Bharat now. Find we will try to find out this model, this odds is equal to beta plus beta 1 x1 plus beta 2 x2. Okay, and we will be able to find out these coefficients. We are done. We find out that probability as well. Probability is all about. So, so it is ln divided by 1 minus p, and this uh, the x1, x2, x3. So if you know these coefficients, you find out the value of p as well. So let me how p1 minus p would be equal to e power plus beta 1 plus beta 2 beta naught plus beta 1 x1 x2, and from here the value of p, as we started with beta beta x1 divided. Same. So if you know these coefficients beta naught, beta 1, beta 2, you can find out the probability. Customer, if some new customer is coming, you know the value of x1, x2, and all. So you put here x1, x2, x3, 3. You already know the coefficients beta naught, beta 1, beta 2. That will give you the probability. This is Bharat, Krishna. And why I converted uh, from 0 to 1, I use that option descending, because convert it time and again. So let's use this p. Let's more convergence status. To do much about this, it describes whether the maximum likelihood algorithm has converged or not. It tells you what kind of convergence criterion is used to uh, assess the convergence. So I have used relative gradient. Criterion is 10 to the power minus 8, which is meeting here. So worry about this. We have model fit statistics. So here it is giving you values for each criterion. For it is giving you two values. For SC it is giving you two values, and for minus 2 log L it is giving you two values. Value is for the intercept only. Second value is for intercept and covariates. So it is very much like we have done in regression, linear regression. AI abbreviation, which actually stands for a key information criterion. It stands for a key information criterion. For you, AKE, a key information criterion. Okay, of a key information criterion, better would be the model. So intercept only it is showing you, it simply means that when I have not considered the codes, I mean to say the variables, not considered the independent variables, a confirmation criteria is coming out to be 1223.729. One consider the inter and codes both. Once you have considered, when taken the independent variables into the account, the confirmation criteria has dropped down to 174.448. Let me tell you these about these three criterion. They were given here all the three, and one of these three would help the cause. A kind criteria, if taking that's more than sufficient, then you need not to look for these two. Information criteria as well as SC is derived from minus two livelihood. If you want mathematical formula, but that is not required. But uh, minus 2 log L minus log likelihood, both a confirmation criteria as well as difficult for me to pronounce its term Schwarz. You Schwarz, Schwarz. Schwarz. Criteria. So criterion it is. It find with the help of minus 2 log likelihood. So instead of looking for the 3, you can only look at this Akaike information criteria only. If you add 2 to minus log likelihood, you will arrive at Akaike information criteria only. Can you put the formula for next observation to determine fault or no fault? Chris, training and test after explanation of this. First of all, let's look at these numbers, how to interpret these numbers. Okay, so I explained you what SC mean, what is SC, and what you have as -2 log likelihood. Let's come to the interpretation part. Attention to that only. So talk about -2 log likelihood. -2 likelihood as DNs. E V C E. Okay, it is DNs. This has middle deviance and residual deviance. It is technology. So null deviance is something which that you don't have any variable involved. Variable. So it very much your mean when you involved any variable. So you should remember that diagram in which I showed you total deviation. So we have deviance y minus y bar. Rick was able to explain some part of it, and some part of it was not being able to explain. You see the total is 1221.729. You include the intercept as well as covariates, this gen has come down. And to make it easy for you, you can compare it with SSE. It is the explained part. So you include the variables into your model. This SSE came with something good model. It is something new model. If you need to understand it better, you compare it with, you can draw a parallel because you have already learned regression. So you draw a parallel now. So instead of AIC, you can compare it with adjusted R square. Where the numerator as well as denominator by corresponding degrees of freedom, we get value of adjusted R square. So it is also calculated by taking care of the degrees of freedom. By taking, so degree of freedom, what does this mean? You have taken the number of observations and taken the number of variables into account as well while calculation. Actually serves the purpose of adjusted R square. Okay, both things have come down, so it simply means that uh, this model is pretty good. SE or say deviance actually see how much is not explained by variables. Okay, Ranjan and everyone else. Next matrix will a lot to understand how good this model is. Come to the next matrix. This matrix is a global null hypothesis. Beta equal to 0. You again in ANOVA in regression was used to check the overall feasibility of the model. The thing is done here. Okay, this test to check the feasibility of logistic regression model. The p value is coming out to be very significant in all the three tests. Ratio is something which we are interested in. Our tests also giving you the same information. Since you know about this SAS, it throws everything out, but getting values uh, very significant from all the tests. So let me tell you what is the null hypothesis here. Here, the null hypothesis here is that the without uh, the model, the deviance without uh, dependent variables and the deviance after considering the variables are not simply different. Same. And by looking at these p-values, there are the numbers, but these p-values would make the decision properly. So there is a big difference between these deviance values, but p-value will help you to get that hypothesis as well. So the hypothesis is that this deviance and residual deviance both are same. They are significantly different. This is hypothesis. Now hypothesis you can reject by looking at this p-value. Please understand anything. I just don't want to rush the objects to make you understand. Model, yes. That's why it's global null hypothesis. So the hypothesis is checking null deviance is equal to deviance or not. So this is deviance, this is your residual deviance, which you are able to reject by looking at this p-value. Yeah, right. What about is able to understand it? What else? Understand it here, otherwise it will be difficult for you to understand. I'm thinking the way learned in Russian. It's learning thousand things, uh, very the things from each and everything. It's better to learn few things, getting a good hold of those things, so that further learning can be easier. So you get H naught, and you will say that this model is pretty much feasible. No correlation between dependent and independent variables. Uh, let's horses. Likelihood. I told you this is called deviance. You can draw level, consider it as error of squares of error, errors of square are decreasing here. Okay. Yes, yes, yes. They are. Notice that there is no significant difference, but you can, yes, you can see here there is a significant difference because the p-value is coming out to be less than 0.05. Anybody move? Telling me that I was fast. I have not been fast. That difference is small. Would you just? So that is what is being tested by the null hypothesis. Some people call it small. People call it big. 1 million. It is only one. Okay. Now some people will call 1 million as a small if they are working for a big company. If they are working for a small company, they'll call 1 million as a how to get to a statement whether the significant difference or not the value, and that's why you are coming to the next block. So first only telling you that yes, deviation drop down, residual deviance is less than null, but the second block is actually telling you interpret in a way that will help you to make a statement that yes, there is a significant difference between the null and residual deviances. You get a point, Niranjan, that we are getting into the next block. Good. Any question? Because yeah, it was a very relevant question. Thanks for asking. Okay, let's go to the next block. Maximum likelihood estimates. In multiple regression, that perform multiple t-tests variables causal or not. Coefficients are equal to 0 or not. The C will be doing here as well. Okay, 0.0003 significant, but if you look at cards, it is not coming out to be significant. Out to be significant, and residence again is not coming out to be significant. So you decide to get rid of these variables as well, or need to look at uh, variable, and you might need to take out the outliers, and you might need to increase sample size. There may be different ways, but these estimates are, that is something very important to understand. How will you make the equation with that test? That is very important to understand. Now I would be able to answer your question. So you were asking me about that equation, which may help me, which to derive uh, value of D for any new customer. Brenda, so all these here. So write it like this. P by 1 minus P equal to, this beta naught here, minus 1.5 8 my 0.0214 to age plus my new cards dot 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 dot. Equation, and any new customer is coming up, we can put here or her age, and we can find out the value of P. Okay, so the logic, these uh, estimates, these binary logic regression estimates for the parameters in the model. Okay, you have seen it already that the logistic regression models, the odds for a positive response d is equal to 1 example is a linear combination of the predictor variables. Okay. So how you interpret it, these estimates. So for unit change in the predictor variable, the difference in log odds for a positive outcome is expected to change by the value, by this value. Okay, variables are held constant. This is how to interpret these values. Change in the predictor variable, the difference in log odds for positive outcome is expected to change by, so if looking at age, so measurement for age, for 1 unit change in age, the difference in log odds for outcome is expected to change minus 0.0214 are held constant. You got. So let me tell you what odds ratio is all about. It's the this. So let me come to the next matrix. Now have all understood this? Any questions so far? 10 minutes left, but let's complete. Let's finish logistic regression today. It might, another minute or two. Let's with me. I will not in any question. Okay. Myth then of what we have done in the last matrix. So the values when the estimate is exponentiated. So if you will out the e raised to the power minus 0.0214, that gives you 0.79. Power, this value will give you 1. These are exponentiated values because you get values with found when you use logic regression model, where combination of different independent variable is equated to odds. Here, these exponentiated values. I mean to say that this value is power 0.0214 for the rest of them. And if you're taking 95% confidence interval, here getting the point estimates, it will give you the interval estimate from this value to this value, from this value to this value, from this value to this value. Estimate is exponentiated, the odds ratio becomes odds ratio. Ratios. How we interpret one? Can anybody make an attempt? The way I helped you to interpret these values. So odds ratio you can interpret in this way. For 1 unit change in the predictor variable, so talking about age. So for 1 unit change in age, the odds ratio for a positive outcome expected to change by 0.979. Variables in the model are held constant. Positive outcome means default is equal to 1. We every time that we have default is equal to 1. All these probabilities are calculated for default is equal to 1. Positive outcome, or you can call it as a favorable outcome. To understand the last bit, you have percent concordance, percent discordant, and percent tight and layers. So basically, when you build the model, you look at that model from different perspectives, whether the model is good enough or not. Concordant and discordant percentage also gives you whether it is good or not. To understand this, we need to get into it. I have created one Excel for you to make it better for you. To find that Excel because I had closed that. But let's start our discussion with the number of pairs. So number of pairs are 210,000. 10,000 pairs are there. Can you guess what this pair means? And I will find out that Excel. No, I'll tell you what these pairs are. So in the original data set, you have 300 observations, 300 records where the default variable is 1, and 700 records where the value of default variable is 0. So this number 210,000 actually tells you pairs. The number of pairs you can form 1 and 0. Everyone pairs. Good. So I have kept here this example. I from Google only, and I saved it so that I discuss it very fast. Otherwise, it takes time to explain you in plain English. So I have these values, uh, these other values, or suppose default. Observe value, the variable default. So there's 1, 1, 1, 0, 0, 0. Okay. So the observe values with this model, you get different probabilities against these values as well. Model, if you'll run the model on these values only check your data, how good your model is. You run the model on the existing data and get some probabilities. Are these values predicted probability values? And I'll again try to draw that parallel with the linear regression. Oh, every time I do anything. Multiple linear regression, if you remember, we have point that way, and we were taking one value of y hat that was for value of independent variable x, and how you got y hat. Y hat you got by input x into the model. Set that model in terms of probability. Just a moment. This created from model, you get out the probability value for each record. Those use these. Understand this point. Okay. These are predicted probability values from the model, and these are the actual values, observed values. Do now will find out the total number of pairs. So the operations you have where the default value is 1, and there are 3 observations where default values are 0. If you go and find out the number of pairs would be 9. This is something you can find out by basic probability 3 to 3. With this, with this. Oh. Excel has. Just give me a sec. this logistic regression a lot of time because people find it very confusing, very difficult. They find it. Very true. So pair will be this, another pair will be this. This way you will find out total. Okay, so let's talk about each pair and 0. Let's talk pair. Actually is 1. The value, the probability to get 1 is 0.91, and to get correct value, the probability to get 1 here is 0.75. So concurrence. So I'm creating 3 blocks here, 3 buckets here. I keep doing concurrent pair where the probability 1 in and probability of 1 in 0. So probability 1 is more than probability of 1 in 0. So these all are the probabilities to find 1. Values of probability are the values to get 1. So I would put in concordance this pair. This is 0.91 and 0.06. Again here, probability of getting 1 in 1 is less than probability of getting 1 0. All these type of pairs in concordant. In discordant, you would the out of pairs, in which you have a situation like this. Let's talk about this pair. You have this 0.72 and so is 1 0. Look at this pair, probability of getting 1 in 1. Sorry, in 75. 0.6. Oh. Getting 1 is 0.72 and probability of getting 1 in 0 is 0.75. So of getting 1 in 1 is less than probability of getting 1 in 0. This is called discordant. In other words, let's not talk about too much technical. That's okay. Coming out to be 0.72 of getting. Don't hear a contradiction. X0, but the probability of getting 1 is a big number. It is 0.5. That we are putting this pair into discordant. Point. To close your laptops and end the session, this is a very important concept which I'm trying my best to make you understand. With me. Okay. Pair 1, just a moment. Why pair is concordant? So you are talking about 0.91 and 0.75. Which pair are about? 0.9 and 0.75. If we look at this is 0.91 and 0.75. Humidity is high, but is relatively lesser, that it into content. Help you understand it better. When you look at this probability 0.75, you compare it with the benchmark of 0.5. Not correct. If in this pair you see this value is high, undoubtedly it is high if you are considering 0.5 as a benchmark. Below 5, you find those values lesser, and above 0.5, you use values as higher. From that perspective, this is a high value. But this value is anyways lesser than 0.91. That putting it into concordant. Okay, so define concordant and discordant. Am I making do bucket these different pairs into concordant, discordant. If you have the same number, if the probability is same, then you put that into tie bucket. So a tie, then a tie as well, and find out the percentages. So now there are a total of 9 pairs. Out of 9 pairs, 1, 2, 3, 4, 6, 6 pairs are concordant. So 6.6 divided by 9 into 100. The percentage concordant 9 will be the percentage discordant, and 1 divided by 9 would be tied pairs. How many of you are still able to understand? Please let me know. Don't worry, I'll explain you. About okay. So I'll quickly tell you what test and train data sets are. So divide our two parts: test and train. But I'll quickly create any model. want to test that model. Okay. So model we first of all actually take this issue in my discussion class, but let me quickly tell you what and why, or we can discuss it in tomorrow's class as well. Or let me give it 1 minute and quickly explain it. So you have a data set, total data set here. We have uh, here say 100. We can do. We can keep 70 observations. We can keep 70 records in data set and build our model on trained data set. Our model on 70% of the data. Option a model for model on the test data set. We already know the answers. We already know default variable. So we can do, we can find out the probability values and we can compare with the X values. We can find out how good our model is. So you minimize the risk of overfitting. So it actually helps you. Any question in this, or question from whatever we have learned so far? Have you believe you were thinking about this? Understood? So regression as well. Atrial analysis, something which will not be taken care of in these classes. I have taken care of many case studies. Okay, so case studies are for your practice. Easily removed. I could easily uh, those data sets instead of this. That is something that is done in your test set. That is what I explained to you. Validate your model. So one data set that is also called as test data set, and there is one data set which is called as a train data set. You build model on train data set and then you compare that model on test set. Okay, so I accept now. What you can do, you can data set into two parts. One part, another part has 30%, model on 70% of the data, and then apply that model on rest of the data. No case stat and rock. So there are many other things. As I mentioned, regression is a 6 months course. There are things which are very important, which will help you to explore further. That is those things I have discussed here. So you apply this formula on the test data set, and then you can check what all are matching, what all values are not matching, how many values are matching, what is the percentage, and then you can write about that. Yes, and then you can apply that formula. Next are SAS batches. You can get this confirmation decision from get team. Connect model building in our course. It will be discussed in much more detail, but I believe everything has been covered. There are many other things in regression. Regression, as I mentioned, it's a canvas. Not everything can be covered in classes or in our classes. There will be things which you need to explore. Okay. Okay. Let's keep it till this only. And let's meet tomorrow. Try to do everything before you come to the class tomorrow. We would be discussing times modeling, and some part macro is also left. Thank you. See you tomorrow. Part of survey. Close the lid of your laptop. Trees. Need to think over it, but decision trees I'm anyways be covering in R. But in this version, you have this proc D tree, which is complicated. That we always go for SAS enterprise minor for the decision tree. Covering decision trees. That will be definitely covered in a greater detail using two packages, part and uh, package. Uh, okay. Thank you.